So today we're talking about measures of central tendency and variation. Okay, so the mean is probably what you're most familiar with, which is the average of the data set. So officially it's the sum of your values divided by the number of values that are in that set. Okay, your median, this is important. Not only is it your middle value, it has to be your middle value when the data is ordered numerically. So it doesn't always come to you in numerical order. You have to order it yourself. If there's an odd number of data values, then you have a middle data value. But of course, sometimes we have an even number. If you have an even number, you have to take the two middle and find the mean of those, or the average. The mode is the value or values that occur the most often in a data set. Sometimes there is no mode. So if there are no numbers that occur more than once, then you would just say that there's no mode or none. Okay? So I asked you to find the mean, the median, and the mode for this data. So to find the mean, you're going to add those up. 3 plus 0 plus 2 plus 0 plus 1 plus 2 plus 4. And Tyler, how many data values do we have in that set? 7. So we're going to divide by 7. When you guys are writing this out, I at least want to see this, the 12 over 7. Okay, and then 12 divided by 7, we're going to round to the nearest hundredth. It'll be about 1.71. That is going to be your mean of your data. Right, now we are going to find the median. So again, with the median, the first thing we have to do is line these up. So if they occur more than once, you have to write it more than once. So it should be 0 and then 0, 1, 2, and then 2, 3, and 4. So because I have 7, I can find the middle number. Okay, really what this number does is it splits the data into two different parts. And we'll talk about what we find in those two different parts. So your median is going to be 2. In this case, we have two modes. Okay, Rhea, what are the two modes for this? 0 and 2. So mode is 0 and 2 because they both occur twice. All right, the next thing we're going to talk about is the expected value. So what do we expect the value to be in given situations? Okay, the expected value is the weighted average of your possible outcomes. Okay, so it's a weighted average of all of your possible outcomes. The weight for each outcome is the probability. Okay, so the weight in this case is the probability. So for example 2, we're going to be given a chart, which is the probability distribution of successful free throws for a practice set. That's going to be given in our chart. And then we're going to find the expected number of successes for one set. Okay, so the number of good free throws ranges from 0 to 3. So 0, 1, 2, 3. Okay, the probability of making none of those is a 3 out of 20 probability. Okay, for making 1, there is a 3 out of 20 probability. For making 2, you have a 1/5 chance, which 1/5 is what is a percent? 20, and then you have a 1 out of 2 chance of getting all 3. Okay, so this is 1/2 or 50%. This is 20%. Okay, so together it's 70%. 3 over 20 plus 3 over 20 is what? 6 over 20, and that would reduce to? Okay, so if it's 3/5, do you guys know what that percentage is?
66.
That'd be 6 over if you have 6 over 20, that is going to reduce to divide by 2, right? So it would be 3 over 10, which would be what? Okay, so 30% plus 20% plus 50% equals 100%. All the probabilities you'll see in the expected value should add up to 100. Okay, so to find this, we are going to multiply. So our expected value is going to be, the chance of getting 0 is 3 out of 20. We're going to multiply those. The chance of getting 1 is 3 out of 20, so we're going to multiply those. The chance of getting 2 is 1/5. The chance of getting 3 is 1/2. Okay, and then we're going to do this without our calculator first, and then put this in fraction form. So we know 0 times anything is just going to be 0. So this is going to be 3 over 20 plus, what's 2 times 1/5? 2/5. 3 times 1/2. Okay, so if I'm going to add those together, I have to have a common denominator. Damien, what's my common denominator going to be? 20. So 20, 20, 20. This one's going to stay. All right, and then Gigi, what's my numerator for this one going to be? So
for the second one, right?
Yeah, for this.
8.
Yes, so times 4 times 4. You said 30 times 10 times 10. Okay, so 30 plus 8 is 38. 38 plus 3 is 41. 41 over 20. 20 goes into 41 how many times? Twice, with 1 left over. And then we are going to turn this into a decimal. Just turn it off. Okay. Do you guys know what 1/20th is? Yeah. So like if you know that 1/5 is 0.20, it's 1 over 20 is 0.05. Okay, so this is 2.05. That's the expected number of successes. So this is your expected number of good free throws. Okay, so you're expected to make 2.05, or approximately 2 out of your set. So this is not in terms of probability. This is giving you the number that you have here for n. Okay, so you can expect to make about 2. All right, now we're talking box and whiskers plots, which are something that you have done before, correct?
Yeah.
Okay, so with your box and whisker plot, it's going to show the spread of your data set. Okay, it displays 5 key points: the minimum and maximum, the median, and then the first and the third quartiles. Okay, so you can see your minimum value is here at this dot. Your maximum value is here. Your median, you have a dot with this bar. You have the third quartile, which forms the first part of the box, the third quartile, which forms the end part of the box, and then you are also going to list the interquartile range. When you guys did your box and whiskers class, did you guys talk about the interquartile range as well, the IQR? Okay, good. So some of that will be review for you. All right, so with our quartiles, the medians of the lower and upper halves of the data set are how those are formed. If there is an odd number of data values, then you are not going to include the median in either half. So if there's an odd number, do not include the median. In either half. Okay, so the quartiles are the medians of the lower and upper halves. For example, if we use the one that was on the front page, because the 2 splits this, okay, you would not use the median. So you would find the median of the lower half. What would be the first quartile here? 0, because 0 is in the middle. Okay, what would be the third quartile? 3, because 3 is in the middle. Okay, and then your range, your interquartile range, is formed by finding the difference between the first and the third quartiles. So whatever you get for your third quartile, you're going to subtract your first quartile, and that is your IQR. And then your IQR represents the middle 50% of the data. So because we're talking about central tendencies, we are very interested in that middle set of the data. Okay, so for example 3, we are going to make a box and whisker plot, and then we are going to find the IQR. So we're going to make a box and whisker plot, and then we're going to find the IQR. Okay, so here's our data set. The first thing we want to do is order our data from the least to the greatest. Okay, so when I do this, I'll tend to like cross it off as I find it. So I have 4, then my 5. I have 2 6s, 1 7, 2 8s, and then a 9 and a 10. All right, so how many values do I have in my data set? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 values. And then this says to find the min, the max, the median, the quartiles, and the IQR. So your minimum is always going to be your smallest value, 4. Your max is always the largest value. In this case, it'll be 10. To find the median, if I have an odd number, it's going to be that middle number. So I have 4 on the lower bound and then 4 on the upper bound. So my median is going to be 7. That's the middle number. And now I'm going to find my Q1 and my Q2. Okay, so to find Q1, I have to find the median of the first half. Well, in this case, I have 4 values. So the 2 middle values, the 5 and the 6, I have to find the mean of those, which is just the average. So to find Q1, I'm just going to add 5 plus 6 and divide by 2, which is really just what value is in between 5 and 6. Yeah, 5.5. And then you're going to have to do something similar with Q3. What number is between 8 and 9? And again, this time it is very easy to see because you have all whole numbers. Okay, and then, oh, I am going to just write the Q3 as the median of your second half. Okay, so then your Q1, 5.5, Q2, 8.5, and then you have to find your IQR. So your IQR is Q3 minus Q1. Oops, I put Q2, sorry. Q1, Q3. So 8.5 minus 5.5 is 3, so that's going to be your IQR. All right, when you draw your box and whiskers plot, you are going to need to make a number line. That's why you guys have a straight edge on your desk. And then what I want you to do is make sure that you label your key values on your number line. So when I say key values, I'm talking about everything that we found in step 2. Okay, so I'm going to use my straight edge. I think I started mine at 0. Gonna have to go up to at least 10, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so then what I'm going to do is plot my points for my min and my max. So at 4 and 10. My next one for the median is going to go at 7. So 5, 6, 7. So I'm going to label that on my number line. My first quartile is at 5.5. So I'm just going to put a little dash here. 5.5. And that's where this point's going to go. The next one is at 8.5, so I'm going to label that. Okay, so now I have all my key values labeled. And then you are going to connect the first 2 with a straight line and the last 2 with a straight line. And then you're going to make your box. And then you have a line just going straight through your median. The last thing you have to label is your IQR. Okay, so it starts at 5.5, goes to 8.5. So this is how you're going to label your IQR. Okay, questions for me on that? Do you guys understand what I mean by labeling the key values? Okay. All right. Now we're going to get to hopefully some newer stuff. Have you guys heard of variance and standard deviation before? If you take AP Stats, you'll be working with this a lot. So we are going to talk about variance and standard deviation. So first, the measure of variation, that is going to be a value that describes the spread of data in a set. Okay, so any measure of variation is just going to describe the spread of the data, so how far spread out it is. Some commonly used measures of variation are the range. So the range is formed when you subtract the max and the min. Your IQR, which we already found that today. Finding the variance, which is what we are going to find. And then the standard deviation, which we're also going to find. So before we find those, we are going to define them. So first we have variance. Okay, here is your symbol for variance. Have you guys seen this symbol before? Do you know what it's called, anybody? Okay, so this little guy here is sigma. It's a lowercase sigma, so this is sigma squared. Okay, and this is the lowercase sigma. The uppercase looks like an E. It's, yep, it's for the sum. Okay, so the sigma squared, that is the average of the squared differences from the mean. Standard deviation is denoted by what? Well, we just said this was sigma squared, so what's this guy? Just sigma. So if we had sigma squared and we had to find sigma, what would we do? We take the square root. It is the square root of the variance. And it's one of the most common and most useful measures of variation. And then this is just your sigma. Right, so you can have a low standard deviation or you can have a high standard deviation. If you have a low standard deviation, that indicates that the data is clustered at the central tendency. Okay, so it's clustered at the center of the data. So low standard deviations indicate data that is clustered at the central tendency, while if it is a high standard deviation, I guess that should be lowercase, they indicate data that is, what do you guys think? Yep, that's spread out from the center. So really understanding that part is very important. We're just going to make some notations in simpler terms. Okay, so if you have a low standard deviation, what that means is your values are close together at the middle. Okay, so your values are close together at the middle of your data set. Okay, if you have a high standard deviation, that means that your values are spread out from the middle. Okay, so a really simple way to think about this is in terms of like scores. So if you have your average test score, let's say it was 85%. If you have a small deviation, standard deviation, it means that most of the scores are around that mean value. Okay, and it can be like a mean or a median. If you have a high standard deviation, then even if your mean is 85, they're going to be spread out from that center. So it would be to get the 85, you'd have some that were really high and then some that were low. So they aren't close to the 85, but when you average them together, you would get that middle value. Okay? All right, let's find some of this. So in example 4, it says to find the mean and the standard deviation for the data set of the number of people getting off and on a bus for several stops. And then we're going to have some more notations here. Okay, so for this it says find the mean, and then see how it's an X with a little segment above it here? This is called X bar. And that is your notation for the mean. Okay, so that's what we're going to be using. Okay, so for that, we're going to add them all together, divide by the total number. So I'm going to give you a minute to do that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 total. And then let's add those together. Joe, what'd you get for your total?
63.
Yep. Okay, so when you add those together, you'll get 63 over 9, which is exactly 7. So then your x bar is going to be 7. That's your mean. Okay, in step 2, we are going to find the difference between the mean and each data value, and then we're going to square it. Okay, so find the difference between the mean and each data value, and then we're going to square it. Okay, so the data value is going to come from this. So we have 6, 8, 7, 5, 10, 6, 9, 8, and 4. Okay, we're going to think of that value as x. Okay, so here when it says x minus x bar, we know x bar is the mean. So this is really, you're just doing x minus what? 7. Good. Okay, so then for the first couple, I just wrote in what I did here. So to do 6 minus 7, I got -1. Now I have 8, so this is 8 minus 7, which is 1. 7 minus 7, which is 0. 5 minus 7, which is -2. And then we're just going to keep going. Okay, so can you guys fill in your top values? I see some of you guys using your calculator, and that is disappointing. Really, this part should be really quick, right? It's going to be faster to do it without a calculator. So this, you're doing x minus x bar squared. So you're just doing the squared difference here. You're doing the square of what you found here. So -1 squared is 1. 1 squared, 1. 0, 4, 9, 1, 4, 1, 9. Okay, remember that when you square a number, your value is always going to be what? Positive. Okay, so now we're going to find the variance. To find the variance, that is the average of the squared differences. Okay, you already found the squared differences, right? So here were the differences. This was the squared differences. Right? Here I found the difference. Here I squared it. So aren't these just your squared differences? Okay, so then I just have to find that average. Okay, and then we're going to use our proper form. So this is our symbol. So I'm going to do 1 plus 1 plus 0 plus 4 plus 9 plus 1 plus 4 plus 1 plus 9. And then I still have 9 values. If you did have to do this without a calculator, I would start adding ones that you know are going to be 10. Like 1 and 9 will be 10, right? This will be 10, so I have 20, 24, 28, 29, 30. Okay, and then we're just going to, actually this one is a repeating decimal, right? The 3.3 repeating. So that's how we're going to write that. All right, and then for step 4, we are going to find the standard deviation and we already talked about this, right? If you're finding the standard deviation and you already know what the variance is, you can just take the square root of both sides, because you have sigma squared equals 3.3 repeating. So we're just going to take the square root. So when you do that, don't use a rounded value. So you have the 30 divided by 9, and then you can do the square root of your answer. We're just going to round that to the nearest hundredth. So I have 1.825. The only thing I look at is the 5. It's right after the place that I want it to be. Okay, so we rounded that to the nearest hundredth. Okay, and then so your solution was to find the mean and the standard deviation. So your mean is this, and the standard deviation is this. Okay, and again, that's just what we did from the directions. You're finding the mean and the standard deviation, so that's what we got. All right, so based on what we did for this one, I want you guys to go ahead and do example 5, part C. Okay, so find the mean and the standard deviation for your data. Okay, so you guys can do that in your group. And again, remember, I do want the sum for the first one. Make sure you just put that on the top. And if you notice that you have the same data value, the difference isn't going to change, so you don't have to punch that into your calculator more than once, okay? Like there's lots of 18s, right? The difference between that and 21.9 isn't going to change. And then when you're done, you can check with their table and see if they got the same thing that you did. Alright, so let's check to make sure we got the right mean, the 21.9. Okay, I filled in your chart so you can double check to see if that went right, if your final is not correct. So the variance, when you do the sum divided by the number of values, you get 22.89. So to take the square root to find the standard deviation, you have 4.78. So we know that the mean is the average. What the standard deviation means is your data values are usually around 4.78 from your mean. So most of your data values are either about 4.78 above the mean or below the mean, which really makes sense because what was the mode here? What's the mode for this data set? 18. Okay, which if we're thinking of our mean around 22, this is around 5 less than that, it would be around the 17 mark. Okay, and then your highest value, your 30. All right, your homework is on your calendar, which I'm gonna put up for you.